Hello. Okay, everybody's coming in. I'm going to switch to screen sharing. Okay, you should see the desktop. I'm setting things up. Does everybody hear me?
Yes.
Okay, audio's working, and you see the desktop, right?
Yes.
Okay, great. Thank you. And okay. Okay. Let's see where to start. Okay, first thing, the most important thing is the first midterm is coming up soon. In fact, on the syllabus, it was supposed to be this week, but I didn't get a review up in time. So we're going to postpone the exam by 1 week. So if you look on the syllabus, I'll probably go update the syllabus. The syllabus said September 23rd, which is this Wednesday. Okay, so that'll be, pardon me?
How will this exam be taken?
Okay, well, yeah, we'll get to that. Okay, so let me just show you first the exam. The exam will be a week from today, or a week from Wednesday, so it'll be on the 30th. And here's a list of what we've covered so far. This is what the exam is going to be about. Chapters 1 through 5 of the Think Java book, and these sections of chapters 1, 2, and 3 of the other textbook. So we've gone through, we're working through chapters in 2 textbooks. And then here's kind of a list of topics, just to give you a sense of what words we've covered. We're going to start talking about if statements, maybe today, certainly on Wednesday. So we'll do a little bit about if statements this week, and that'll be one of the things on the exam. And then here's a bunch of more problems for you to work on. These are exam-like problems. Okay, so there's about 20 problems here, and I'm not quite finished with this. So as I point out on this page here, the list of problems is not quite done yet, so I'll be updating it soon. I might drop a couple and add a couple. So this list here is not quite done, but it'll be done today or tomorrow. But this is a good list. This is a list of the kinds of problems that you'd expect on the exam. Now, the exam will be, like I say, problems like these, which are, you're asked to read code and says what it does, or write out what the code would print out. Like in this one, you're supposed to show what the code would print out, okay? Or you're supposed to explain what code does, okay? So the exam will be, the exam will be on Brightspace, and you'll download it. Probably you'll want to print it out, fill out the exam, and then you'll upload it back to Brightspace. And what I'll do is I'll make the exam available at the end of class on Wednesday, and it'll be due like at midnight on Wednesday. Give you time to work on it during the afternoon. Instead of having a timed test, which isn't going to be very easy, because you're going to have to scan your test in and upload it back to Brightspace. So there's a lot of well, not a lot, but there's a little bit of overhead in here. You have to download it, print it out, write your answers on the exam, use your phone or a scanner to scan the exam back in as a PDF document, and then upload it back to Brightspace. So it'll be, when we get to Wednesday, after class, the exam will be available right after class, and it'll be due at midnight. That gives you, I don't know, 10 hours or so to do the exam. Okay, and that's how we'll do it. So you'll do it at home, and you'll write your answers on your paper and scan them in, scan your pages in, and upload the exam back to Brightspace. Okay, does that sound okay? Okay. Yeah. So it's mostly a chance for you to show that you're keeping up with the material. Okay, so the exam is really kind of it's acting, I think, as a good review of what we've done. So these review problems, and then you solving a few the exam will be about 10 problems. There's actually about 20 problems here. The exam itself is about 10 problems. Okay, and it's actually, it's going to be pretty much the exam I gave in class before, which was meant to be a 1 hour exam. So it's an exam that if you, yeah, I expect people to be able to sit down and do it in an hour to hour and a half. Okay, so it's not 10 hours worth of work. It should be, if you've done the practice problems and if you're ready to take the exam, it's about an hour to hour and a half of writing to think and write out the answers. So it's about 10 of these kinds of problems here. Okay, like I say, and all these problems, uh, none of these problems really ask you to write more than a line or two of code. There's actually, most of them don't ask you to write code. They mostly ask you to read code. So the vast majority of these lines are ask you to read code or to fill in some missing, like here, you have to fill in a few missing lines of code. Okay. Another one is here you have to fill in a couple missing definitions. Here you have to fill in a couple missing definitions. So you're not writing code for the exam. It's mostly reading code and answering questions about it. Okay, and writing your answers. The answers could be explanations, or your answers could be completing a line or two of code, or your explanation might be just saying what the output looks like in this code. What does this code print out, or what number does this code give back as an answer? Okay, right. So the answers are, for the most part, short answers. The answers are each answer is a few lines. Oh, these ask you to write a couple lines of code. So like these three problems here, for each one you'll write about 3 lines of code. Okay, define some variables. Okay, so the exam is meant to be a review of what we've been doing, to see that you understand the ideas, the words and ideas that are in this list here. Okay, so it's not an exam where you have to write a 20 lines of code or solve some complicated coding problem. It's mostly an exam where you're asked that you understand these ideas here and show that you understand them by answering short questions. Okay, all right, so, oh, and these review problems are review problems. If you have questions about them, you can ask me questions about them. If you talk to other students in the class, if you're friends with people in the class, if you know people in the class, you can talk about these problems together. So make sure you should try to solve as many of these problems as you can before the test. These are really good review of what we've been learning. If your goal is to learn to program in Java, solving these problems is very good review of all the ideas we've been talking about. Okay, writing code is not the only way to learn programming. Solving questions like these, answering questions like these, is a good way to make sure you understand the ideas. So these are review problems. They're not. This is not the exam. So if you have questions about these, if you talk to your friends about them, you can work together on these, but make sure you can solve these problems. The exam is not a group exam. The exam is meant to be that everyone would do the exam on their own at home and upload their solution at the end of the exam. Okay, so the exam is something you should work on by yourself, but not these review problems. Review problems are meant to be something that you ask questions about in class. Not today because you won't have time to look at them. But when we get to class on Wednesday, if somebody has a question about a review problem, we can look at it. If somebody's got a question about review problems Monday or next Wednesday, we can look at them. Okay, so if you have questions about review problems, you can ask me an email, you can ask me in class, and we can go over problems. We can go over these problems in class. Okay, so these are the review. Make sure you do the review. Okay, and ask about them and things like that. And okay, let's see. Okay, anybody got a question? Anybody got questions so far? Oh, no, I'm not going to give you. Yeah, somebody wrote in the chat. I'm not going to get. That's a real good point. I'm not going to give you the answers to the review problems because I want people to work them out, and I don't want people to memorize them. So I won't give out an answer. I'll answer questions, but I won't give out an answer sheet. Okay, so that motivates you to work on them, to solve them. Okay, so the one thing I won't do is just hand out an answer sheet to all these review problems, but I will answer any questions about it. And like I say, if somebody has a question in class, we can go over one in class, we can go over a couple in class, but don't send me an email saying, can you give me an answer sheet? If you send me an email saying, this is my answer to number 4, is it okay? I'll look at your answers, I'll tell you if you're right or wrong, but I just won't send out, I won't send an answer sheet. Okay. Okay. Anybody got other questions? Okay. Okay. So let's see. That's this part, review. Okay. And look, these problems, like I say, in the next few days, there might be some more problems added to this. So each day you might want to go look and see if that is changed, at least for a couple days. I'll let you know by Wednesday if it's hopefully by Wednesday it'll be fixed. It'll be done. Okay. Then here is a reading assignment, beginning a topic. We're going to start talking about conditionals and Boolean. Not today. That's what we'll talk about on Monday. And that's actually the last thing that'll be on the exam. That's these items here. Okay, that's what we're going to be talking about in the next week. So these items here and this reading, this stuff here is what we're going to do in the next week. So that'll be on the exam. Okay, so here's the first reading assignment about Boolean expressions and if statements. Okay, and then here's some more homework problems for you to work on. This is a new site. This is a new way of doing problems, something called Coding Bat. These problems are real similar to your programming assignment. Okay, so your programming assignment involves using string methods, like we talked about last week. We talked about string methods. So let me show you what this looks like. This is an online website where you solve programming problems. Okay, and the way it works is eventually you'll see there's lots and lots of problems on this website. Here's one of them. Okay, and it's a Java problem. You can also do it in Python if you want, but we're doing Java. They give you a description of the problem. See here. So what you're doing is you're writing a method. You're writing the body of a method. So you're actually every one of their problems is written this way. You're completing the definition of a method. Okay. They tell you here what the method should do. Okay. This method would be given a non-empty string. So it's given this string as an input parameter. And it's given an integer n. So it's given this integer n as an input parameter. So it's given a string and an integer as an input parameter. And it returns a new string. So it returns, so this method's got a return value, a string. So it takes in a string and it gives back a new string, okay, where the character at index n has been removed. Okay, so in brief, what you're supposed to do is take this string and remove the nth character from it and return the new string. Okay, so take in this string, remove character at index n, and give back the new string. And then what they always do is they show you examples. Okay, so if you take in kitten and remove string index 1. Now remember, 1 is not the first character. 1 is the second character because we index starting from 0. So that would remove the first I. So you'd get back K-T-T-E-N. Okay, if you take in kitten and the index is 0, you remove the first letter. So you return I-T-T-N. Notice that they use an arrow to say that you're returning this string here. So this method with this input will return that string there. Okay, then if the index is 4, that's the 5th letter in kitten, that removes the E. Okay, so this would be the string you return. Okay, now these are warm-up problems. The way warm-up problems work is they actually will give you the solution if you ask them to. So you click here and they give you the solution. Okay, so for example, their idea is that you would write a variable called front and a variable called back, and then you're going to return front plus back. Okay, that's their suggestion of how to solve this one. Okay, so if I take their code and put it in here, let's see what they did. You want to remove the nth letter. So you take a substring of string from the beginning up to but not including letter n. So that's what they call the front. That starts at the beginning of the string and goes up to but not including that letter n. Then back takes another substring that starts right after n and goes to the end of the string. So they call that front and back. Then they add together front and back to get the answer. Okay, now here they gave us the answer. So by clicking on social solution, but now let's see how this works. If after you write your code, you click go. Go will compile and run your code and test it for you. So let's see how this works. So they tested your code. Okay. Now, when they tested it, they said, they do these examples here and some other examples. They say, if the input is this, the output should have been this. And your output was this, which is okay. And if the input was this, the output should have been this, and your output was this, which is okay. Now, let me goof up. Let me forget that in there. Okay. So now I goofed up. This is not quite the right answer. And now you see that they give you, they show you what you did wrong. Okay. When the input was this, you were supposed to have given this output, but you gave that output. And they kind of tried to, they highlight the part that's wrong in red, though it's a little bit confusing. But they're showing you your output should have been this, but your output is this. Your output should have been this, but your output was this. And then you have to kind of figure out what you did wrong. So they'll show you which ones you did right and which ones you did wrong. Here, they turned out all wrong. But you have to then go back and fix your code and try to figure out what you did wrong. Okay. Now, in my case, I need to put that back in. I need to go back here and put that in. Okay. Actually, let me do another mistake. Okay. Oh, that's still all wrong. I don't think I can make it so that some are right and some are wrong. In this case, it'd be hard for me to make it so some are right and some are wrong. Let me just. Oh, there. Okay. Notice by chance, I got some right, most wrong. Okay. So your code might be partially right, but even if you've got one, this is an example of how interesting programming is. It doesn't matter if you got some right and some wrong. In the world of programming, your method is wrong. It's not doing the right thing. It's not as if your boss would give you partial credit because you got some right outputs, but you had some wrong outputs. When you write code, it's supposed to solve the problem. This is just letting you know that you did solve the problem. You got some. Your code will sometimes get the right answer, but most of the time it gives the wrong answer. If your code even gives one wrong answer, your code is not correct. Okay, so they try to have enough tests so that they'll be pretty confident that when you pass all the tests, your code is correct. But that doesn't always work that way. It's not. It's actually possible for your code to pass all their tests, but still not quite be right. But in this case, they try to make sure there's enough tests. They try to test for all the things they think could go wrong. So when you pass all their tests, you're pretty sure your code is correct. Okay. And one of the things we'll learn about programming as we go along is that coming up with tests turns out to be just as important as coming up with code. And in the long run, code and tests always go together. Okay. Because if you have code and no tests, you don't know if the code is correct or not. And if you have code and only a few tests, you don't really know if you're doing the right thing or not. So you need you need to write code, and you also need a lot of tests. And that's a big part of programming. In companies, there are people whose job it is to just write the tests. It's quite often the work is divided. There's people who write the code, and there's people who write the tests. And then the code written by the people who write the code is run with the tests written by the people who write the tests. And then then each one of them works together to try to make sure that the code is correct. Okay. So code and test go together all the time. And that's one of the things that this website does real well of giving you a sense that you have to test your code, but they write the test for you. They generate the tests. I want to point out that this website, sites like it are now being used for doing job interviews. This has actually become a pretty common thing in the computing industry. There are companies that create websites like this one, but they use them for testing intern applicants and job applicants. And what they do is they give you a problem on their website, and they watch you code. You have to type your code in, and then your code is run, and they see if you did it right or wrong. But they literally use websites like this for testing persons. I mean, I'll show you one. This one is a popular one. This is one that's used by a lot of companies. This website is rented. Essentially, they rent themselves out to companies. See, so for companies, companies can pay this company money to give them problems for their interview applicants. Okay, okay. So this website works for both people. You can use it as a developer for practicing your skills, and you can use it as a company for testing your applicants. Okay, and it's got hundreds and hundreds of problems. There's hundreds and hundreds of problems up on this website. A lot of people use it as a practice website. Now, this website here is way beyond what this course is. This is a website for testing people applying for jobs. So it's not a beginner website. But later on, I'll show you what one of their problems looks like. It's a lot like this. They look a lot like this. The setup is very much like this. A box for you to type in code. You press a button. When you press the button, your code is compiled and run, and then you get an output like this that shows you what you did right and what you did wrong. So their problems look a lot like these problems. Now, these problems are geared for freshman programming. So here's their homepage. They've got bundles of problems. Each one of these is a bundle of problems to test you on different topics, and we'll use problems from these different topics as we go along. Like these are string problems, logic problems. String problems are what your second program is, your third programming assignment is about. Logic problems are what we're going to start talking about later this week. We're going to start talking about logic problems. That's the if statements and Boolean expressions that are in the next reading assignment. So they have, if you click on here, there's a whole bunch of problems here. Every one of these is a problem. Now, any problem is always the same. A description of the problem, example inputs and outputs, then the place for you to put your code. You run your code, and now, see, mine, it didn't even compile because I didn't type any code in here. Okay. Okay, notice that I typed in one line of code and I passed half their tests. That's because the answer is either true or false. So that's like flipping a coin. If you flip a coin, half the time you're going to be right. Okay, so just by returning, now if I return false, I'll be right the other half of the time. Okay, but notice how all their problems are the same way. A description, they give you some examples. You write your code here. When you think you got it right, you click go. If you've got some right and some wrong, you can make changes to your code. The idea is that you will make changes to your code until you get them all right. Okay, and it works like that for all the problems. You can keep trying as many times as you want. There's no time limit. There's no limit to this. You can just keep modifying your code until you've got all their tests right. Oh, notice that they have a thing down here, other tests. They actually hide some of the tests from you. So these are the tests they show you. So then if you pass this, you've passed a bunch of hidden tests. And these other websites do the same thing. They all do that. There's going to be some tests that they hide from you. Okay. They want you to they want you to, just because you pass all these tests, there might be some others that are subtle, hard tests that they don't want to tip their hat at you what they are. So they'll just have other tests down here, and you either pass them or you fail. That's where things get really difficult, when you just know you failed something and you don't know what it is. And that's what real programming is about. That's where the real challenge is, where there's tests that you're not even sure what they might be, but you have to figure out what you're missing. Okay, so we'll see more harder problems like that later on. Okay, so all right, so this is a good kind of thing to do. This is a good way to practice. Okay, so on this website, I gave you 3 of their warm-up problems. Okay, so 3, like this one. Well, this one, this one that's got the solution. This one also has got the solution if you want, try it, but the solution is right there. Okay, this one doesn't have a solution button. Okay, so this one you have to solve it. There's not going to be a they won't give you, if there's no solution button, they don't give you the solution. You have to keep trying until you get the answer. Okay. All right, so work on those. these problems are not, especially these warm-up ones, they're not real hard. 15 minutes. If you should be able to solve it in 10 or 15 minutes. And trial and error. Type some code, see how close you get. Make some changes to your code, see how close you get. You can think on your feet with these things. You can think while and even when they do this kind of stuff professionally, they expect you to make mistakes, fix them. When they use these things to test people with, they watch you code, they watch you make mistakes, they watch how you fix things. They don't expect anybody to not make mistakes, but they expect people to think about how to fix their mistakes. Okay, here you can type code, you'll make mistakes, you'll fix things, you'll make mistakes, and you iterate on fixing until you get the right answer. Okay, so the idea is to work on the problem until you get the answer right, not to just sit there, type something out. If you get it right, you're done. If you get it wrong, you go on. If you get it wrong, which you almost always will the first time, you just keep working at it. Okay, all right. So we'll use CodingBat all through the semester. It's a great place for you to practice programming, especially when as I point out that it's the kind of style of learning that companies are using very often now. It's become our student. I mean, our students who are juniors and seniors who are applying for internships and jobs are being sent to sites like this to solve problems. Companies really do use this at this point. This company is in business to help companies test people, as interviewing techniques. And it's got nothing to do with the epidemic. These people are around for years. Companies have been using these testing sites. It's just a good way to test people. It's a good way to interview people. It's even if you're in there, if you're having an on-site interview, they might just put you at a table at this website. 2 or 3 people might sit around you and watch you solve a problem on this website. It has got nothing to do with really remote. They talk about here remote hiring. That's because right now there's a problem with people aren't interviewing on site anymore. But they on-site interviews use this website. They used it for years and they'll continue to use it. It's a good way to interview people. Okay? And this is a good way to get started with that way of learning, or that way of thinking, of solving problems until you got the right answer. Okay. All right. So that's a new thing for us to work with, these CodingBat type problems. Okay. Let's see. Okay. Now, this was the reading assignment for today. Okay. Oh, actually, this is not really a reading assignment. This is just a summary of this chapter. I think it's a nice summary. This chapter has got a few problems. So it's really, especially considering the exam, I gave you a summary on the exam that's similar to this. This is just some of these are the words you should know, the ideas you should know. So that's not really a reading assignment, but it is a good thing to there's nothing new in there. It's a good summary. Okay, so the reading assignment was this math class. Now, let's go back and review what we were talking about. We were talking about methods and objects. Okay, now we have 2 examples of objects we've done a lot with, strings and turtles. So here is a string object. Okay, and we had other code that used turtle objects, and what we're doing is we're calling methods here, calling methods on a string, calling methods on a string. Okay, so that's the key idea here, is to create an object, give it a name, and then call methods on the object. Okay, now there's a picture that goes along with that. Let's see, where's the picture? Okay. Okay, remember a picture like this. This is the variable that gives a name to the object. Okay, we call these memory diagrams. And this is one of the things you have to be able to do on the exam. I'm going to ask you on the exam to sketch memory diagrams or to look at memory diagrams. This is In a memory diagram, you have a variable that points to an object, okay? And the code that does that would be, I didn't type, the code isn't, this is just a picture of the memory object, but the code would be, oh, let's see. That was from the turtle code. Okay, let me clean up this. Okay, here's the turtle code, okay? So this created turtle variable, this created turtle object, and this made the arrow from the turtle variable point to the turtle object. That's that. So that pointing to that was one line of code. The variable pointing at the object would be that one line of code there. Okay. Now, there's this line of code here. That line of code didn't create a turtle object. It created a turtle variable and then put this turtle variable into that turtle variable. Remember, that created this part of the picture. That created a turtle variable, but it points to the same turtle object that that turtle variable did, because they're essentially, you copied this arrow into that variable. This line of code here copied that arrow into that variable. So at this point, you don't have a turtle object here. Even though you have turtle over here, that's a turtle variable. You only get turtle objects when you say new turtle. Okay. Okay. Now there is a, then you go look for uRTL2 in this code. There was the uRTL2 variable with another turtle object. Okay. So this line of code here, this line of code here, and this line of code here created this picture. Okay. All right. So this is one idea. This is these are turtle objects, turtle variables pointing to turtle objects. Then you can also do string variables pointing to string objects. Okay. Okay. So then here we had something similar. Let me close those. Okay. We had a little bit of code that creates string variables. Okay. Now this case, the memory diagram the Java visualizer will draw it for us. With the turtles, the turtles don't work in the Java visualizer. So we can't use the Java visualizer to look at turtle code. But the Java visualizer, what it mainly visualizes for us is the memory diagram over here. So with the Java visualizer, I don't need to draw a memory diagram. We can let it draw it for us. So for example, that line of code, see, it creates the string variable. That's this part of the picture. It creates the string object. Now with strings, you don't have to use the word new, okay? So you can just type this. Though if I go back here, I actually, if I want to, can say new string. I can actually type this just like the turtle was done. So I have a string variable and I have a string object. If I want to, I can say new string hello. But Java lets you, since you use strings so often, Java, let's see, I'll show you. This draws the exact same picture. There's no difference here. See, that still creates the string variable and the string object. Just that Java, because strings are so common in the language, they're used so much, they let you drop the new string parentheses from the beginning here. You can just type quote, HELLO, quote, to get a string object. See over here, they just show you the string object. Okay, so Java has a little shortcut. You can't do that with turtles. There's no way to there's no shortcut for creating a turtle. You have to say new turtle. Okay, all right. Then once you have the object, you can start calling methods on it. Okay, right? So same with, once you have a turtle object, you you call methods on the turtle to make the turtle move forwards and backwards, turn left and right, move its pen up and down. Okay. Remember what those methods are doing is they're changing the variables in the turtle. You're changing data in the turtle. Okay. Strings are a little bit different. When you call methods on strings, you're not changing the data in the string, unfortunately. When it's a little bit more complicated with strings, okay? With with a string, when you call to uppercase, okay, you would think that this would take this, if this was a turtle, you call a method on the turtle, you're changing what's inside the turtle. When you call a method on a turtle, you change what's inside the turtle, the data in the turtle. When you call a method on a string, you never change the data in a string. It always ends up like here. I just executed that line. See, let me go back. Let me go to the beginning. Okay. Execute line 5. I get my string variable pointing at my string object. Execute line 7. Nothing seemed to happen. Okay. I call to uppercase on greeting, and it's still lowercase. Okay. Remember, what that did was it created a copy of this object, and it made the changes in the copy. Since I didn't get capture a reference to the copy just disappeared. So down here, I try it again. I call to uppercase on greeting, but now I give a name to the copy. Okay, so I go down here. Okay, now this is calling this method on this string doesn't change the string. It creates a copy of the string, and I better point something at that copy, otherwise the copy just disappears. It gets created and then just disappears. Okay, so here I created a new variable name to point to that new string object, which was created by to uppercase. The new string was created by this method. Now this is tricky. Turtles are in fact easier to think about. Every time you call a method on a turtle, you're changing the data in the turtle. With strings, every time you call a method on a string, you never change the data in the string. You always have to produce a new string. You produce a new string with the changes in it. Okay? All right. So this is a little trick. And the memory diagram doesn't really show you that. The memory diagram doesn't show you that this thing produced a new string. You just have to know that this thing produced a new string. And that's why I needed this thing to name the new string produced by to uppercase. Okay? All right. Now, so far, we're talking about methods on objects. Okay? So objects are things that hold data, like a string just holds letters. A turtle holds a bunch of things. Its XY coordinates, the color of its pen, the angle that it's pointing at. So a turtle holds a lot of data. We saw a picture earlier from the book of the kind of data that's stored in a turtle. When you call a method on a turtle, it changes the data in the turtle. When you call a method on a string, it doesn't. If it needs to change the data in the string, it has to produce a new string that is a copy of the original string with the changes made in the new string. Okay, so that's calling methods on objects. Okay, now if you go back to the other book and one of the earlier reading assignments, we talked about another kind of method. It's been a couple weeks, but we talked about chapter 4 in this book on methods. These were what we're now going to call static methods. These were not methods on objects. These were static methods. See, they all had the word static in them. It's a different kind of method in Java. You don't call these methods on objects. Okay, you just call these methods by themselves. Essentially, you call them by themselves. So here, see, you just call new line. New line makes you jump up here and do what's inside new line. Down here, you call 3-line. 3-line makes you jump up here and do what's in 3-line. What's in 3-line is a call to new line, another call to new line, another call to new line. Okay, so remember, you have this idea of the flow of control. Your program starts in main, and you do what's in main. Okay, main prints out this, then main says jump to 3-line. So you jump to 3-line. What does 3-line do? Well, 3-line says, well, first jump to new line. You jump to new line. What does new line do? It prints out a blank line. As soon as it's done, you go back to where you came from. Then you do this one that says, oh, well, jump again to new line. When you jump again to new line, you do what it does. Then you go back to where you came from. Then you go to the next line of code, and it says, jump to new line a third time. So you jump up to new line and do what it does. and you're back here. Now you've finished 3 lines. So you go back to where 3 lines was, and then you do the next line, which is print this thing here. Okay. And if you run that, yeah, it all happens real fast. Yeah. Notice this thing doesn't show you the code executing. If you want to see the code executing, you have to use the Java visualizer. Copy. Let's go to the Java visualizer. We can put their code in the Java visualizer. And remember, then we can watch the flow of execution. Okay. So now we can say, oh, it starts here, prints out that. Now it jumps to 3 line. But 3 line is going to jump it up to new line. Then new line prints a blank line down here, which you don't see because it's a blank line, which I thought was kind of, remember we modified this so that it would actually print something you would see down here. But it prints a blank line, which you don't see down there. Then it goes back to where it came from. Then it's going to do the next call to new line. Then it goes back to where it came from, does the next call to new line. Now we're done with 3 line. We go back to where 3 line. Remember, this picture over here showed us that we actually came from line 15 of main. And then we're finished with line 15, so we go to line 16, and we get the last output. Okay, remember, we're watching the flow of control. Now, these methods are static methods. Notice there's no object. We're not calling them on an object, okay? We just write the name of the method with parentheses after it, and that calls the method. So Java has 2 kinds of methods: methods in objects and static methods, okay? So this third reading assignment, up here, was going back to this idea of static methods. See this section here? The math class. So what we want to do now is go, in this book, after they've talked about methods in objects, a bunch of sections, now they go to the idea of methods in static methods. But they use an example that's a little bit different than what we were doing in the other book. Okay. Look at this method call. That's not a method on an object because this thing has got a capital letter in its name. That's a static method that's in this file. Over here, this static method is in this file, and this static method is in this file. That means that the name of this method is really newline.3line, and the name of this method is newline.newline. But since we're in this file, we don't have to use that name. But if I wanted to, I can do the following. This does not change the program. The name of this method is really newline.newline. I'm just using its full name now. I'm using its full name. And same here, I could use its full name, newline.3line. Then I visualize execution. It doesn't change anything. I'm just using the full name of the method. Okay. Static methods, their full name is the name of the file, then the name of the method. Okay. The name of the file dot the name of the method. That's the full name of a static method. Okay. So over here, there's a method called random sitting in a file called math. Now that's part of the Java library. We didn't write it, but the people who wrote Java, they wrote a file called math and put a method in it called random. So since this is not inside that file, if you're outside of that file, to use that method, you have to use the full name of it. Okay, you have to use its full name, math.random. So this is what we call a static method in a file, as opposed to a method in an object. Okay, so now you have 2 kinds of methods: methods in objects or static methods in files. When you have a method in an object, you call the method on the name of the object. When you have a static method in a file, you call the method on the name of the file. Okay, it's a little bit weird. This is the kind of things we have to sort out as we learn Java programming. there's two kinds of methods. The methods in objects, which are actually the far more common kinds of methods. Methods in objects, Java's an object-oriented programming language. Those are the more common kinds of methods. But there is a lot of these static methods, which are methods in files, not methods in objects. See, they're called static methods. And you call them by saying what you have to know the name of the file it's in, and then you give the name of the method. When we did our examples over here, we didn't use the full name because we were in this. See, we were in the file that these methods are defined in. When you're actually in the file that the methods are defined in, you don't have to use the full name. So I could mix this up. For example, I could sometimes use the full name, sometimes use the abbreviated name. Okay. If I'm in that file, I don't have to use the full name, but I could if I wanted to. But if I'm in some other file and I wanted to use this method, if I wanted to use this method in some other program that I wrote, then I would use this method by saying this, by calling it by its full name. When you write static methods in files, what you're really saying is that you're saying these methods are useful. I think other people can use them. So you wrote, now that's not the case here, but you wrote methods that you think are useful and you put them in a file so other people can use them. That's exactly what the math class is. The math class is a file of all these math functions like you have on your graphing calculator. You have all these buttons on your calculator: sine, cosine, tangent, logarithm. What they did is they took all those buttons that would be on your calculator, they wrote methods for them and put them all in this one file, and that's where all the math functions are. So every math function you would need is in this file called math. There's static methods in that file, and then you call them by doing something like this. Okay. So for example, there's a function in there that generates a random number. So this just generates, if you run this, see, it just produced two random numbers. Okay. Let me just do some other examples. I can say math.cosine. I can compute the cosine of, say, 0.5. Okay. Okay. So there's the cosine function is in that. Just like you have a cosine button on your calculator, so there's a cosine function in there, and then you can. There's the cosine of 0.5. You can do the sine of 0.5. That function is in that library. We call that a library. There's the logarithm function in there. Oh, let's see. Maybe they probably spelled LOG. LOG, not LN. Okay. And there's a tangent. So all the functions that you got used to in algebra and trigonometry and functions you might use in calculus and a lot of other functions are in this file. Okay. Random's a nice one. Random generates random numbers for you, which are real useful for playing games. That's how games simulate rolling dice and things like that. They use this math.random function. So the math.random function is real useful for basically for playing games. Okay. So they do a bunch of examples here. They show you how math.random works. From our point of view, what's important here is that what we're talking about are the kinds of methods we wrote over here. Methods that sit, static methods in a file, where you think that these methods are useful. Okay, so you put a bunch of what you think are useful methods in a file, and then you give that file to people, and then they can call your methods by using the name of the file, then the name of the method. Now, this is not an example of useful methods. This was an example that helped us understand flow of control, how the program flowed from one method to another. But this is a very good example of somebody saying, well, there's a bunch of methods I wrote that do math functions for you, and I put them all in a file called math. and that file was made part of Java. So then you can create all kinds of, you can call all kinds of math functions from Java. Okay. All right. Later on we'll see a list of, actually we won't use too many of these functions. Yeah, we're not going to be doing trigonometry and calculus in this class. So every once in a while you might need something from the math library, and when we need something from the math library, we'll see how we'll describe what we need out of it. So, you know, we'll tell you what you need. So for example, here, the random function, very nice little function that lets you generate random numbers so that you can do things like flip a coin, pick a card out of a deck, roll dice. Okay, so the random function is a really useful one. Okay. Now, there's no memory diagram to go with these. Like when you call methods on objects, the memory diagram is real important. So when we think about this turtle diagram, the memory diagram of calling a method on an object is real important because the variable points at the object, the methods modify this data in the object. So when you call like the forward method on a turtle, you're changing the X and Y coordinates. You're making the turtle move. So you're really changing those numbers there. So when you call forward, you're changing what's inside the turtle, and then the Java graphic system draws the turtle for you in a new location. Okay. So what really happens is when you say when you call uRTL.forward, the method call changes those numbers. It's the Java graphics thing that draws the turtle in that new location. But the method doesn't actually draw the turtle. That's done separately. The method changes the data inside the turtle. Okay. So there's a picture that goes with methods on objects. There is no picture that goes with static methods in files. You know, there's not an object there. There's no data that you're manipulating. What's important here is the flow of control idea, that you're going to, like what we did over here. When you call a method, a static method, you jump to that method, you execute the code in that method, and you return to where you called it from. That's the important idea with static methods. You jump to the method, do what's in it, then return to where you came from. Now, we also did these in a more elaborate way. We had some more elaborate examples. Here was a more elaborate one where we gave the methods parameters. Okay. Okay. So here, new line was told to print a greeting with a line number in front of it. Okay. So the method now takes a parameter and two parameters, and it printed the greeting with a line number in front of it. Okay. 3-line took a parameter that was what it wanted to print on each of the 3 lines. So 3-line was to print this message 3 times, and it printed it once, twice, 3 times with a line number in front of the first time, second time, third time. But see, the things are now a method with parameters. Okay. And then 4-line also took a parameter, and it drew a line 4 times. It called 3-line with the parameter, then it called new line once with the line number 4 for the 4th time. Okay, so you can get more elaborate by giving your methods parameters. Okay, but you still have the main idea here is that when you call the method, you jump up to the method, you take that parameter, stick it in that variable, then do what's inside the body. Okay, so when you call a method, the name of the method says that's where you should go to. The value of that parameter gets put into that parameter. The value of this argument, down here it's called an argument. The value of that argument is put into this parameter, and then you use the parameter in the method. Okay. In this case, this means jump up here. The value of this argument goes into there. The value of that argument, which is 1, goes into there. Okay, so then you print 1 greeting. Okay? And greeting is whatever was in here, but whatever was in here is whatever was in here, which was whatever was in here. And whatever was in here was what was in here. But what was in here was Bob. Notice how many things you can go back. You have to go back and trace through so many things. Okay. All right. So we've got static methods in a file, and then methods in an object. Here's another difference between methods in an object and static methods in a file. Over here, see, I call that method. That's the same method. I keep calling that. I'm calling always that method there. There is only one copy of that method. But in objects, like forward, there's a forward in here and a forward in here. The forward in here changes those numbers. The forward in here changes those numbers. We think of objects and methods, we think of methods and objects as actually sitting inside the object with the data. So this turtle object has its copy of the data and its copy of the methods. This turtle object has its copy of the data and a copy of the methods. And the methods in this turtle act on this turtle's data. Okay. With static methods, there's only one copy of anything. This method is just that's the only 3-line method there is. It's that one in this file. Okay. So you don't, even though you might call it more than once, you're always calling the same static method. Okay. Static methods, there's just one of them. But with object methods, you think of there being one in every object. So the turn method, which changes heading. So you can tell a turtle to turn. You call the turn method on a turtle variable, and that turns the turtle that the variable is pointing at. That turn method's inside the object, and it changes the heading inside the object. So this turtle's got his own turn method, and this turtle's got his own turn method. Okay. So you think about these methods quite differently. Static methods in files, there's just one of them. Each named method, that's the method. Okay, there's just one of them. Okay, you call the full name of that method is the name of the file dot the name of the method. Okay, object methods are very different. The method, there's one of them in each version of the model of the object. So we say instance. We call these instances of the model. You could say a copy. It's not really a copy because everyone's different. So the best word for this is an instance. This is a turtle object, and this is another turtle object. So this is an instance of turtle, and this is an instance of turtle. Each instance of turtle, they hold the same pieces of data, but the data in this one's different than the data in this one. This turtle's in one location, this turtle's another location. This turtle's got one pen color, this turtle's got a different pen color. This turtle's pen might be up while this turtle's pen might be down. This one might be heading north while this one's heading east. They hold the same kind of data, but each one holds its own instance of the data. Same with the method. Now the methods are the same, and the methods in this one are the same as the methods in this one. The methods in this one act on this guy's data. The methods in this one act on this guy's data. Okay, so we think of objects as holding their own copies of each method. Each object holds a copy of its own. It holds its own copy of its methods, and its methods act on its data. Static methods, there's just one of those. Doesn't matter how many times I call it from how many times I call it from how many different places. It's always got the name new line dot 3-line, and it doesn't matter how many times I call it. I'm always calling that one. Okay. Every time I call a turtle method, I jump to the turtle method inside that particular turtle object. Okay, so if I call turn on this turtle, I jump to the turn method inside that turtle object. If I call turn on this turtle, I jump into the turn method inside that object. So you still have a flow of control. When you call a method, you jump to the method, but here you jump to the method inside that object, or you jump to the method inside that object. With static methods, you just jump to the method in that file. There's only one of them. Okay. You jump to the method in that file. Okay. All right. So the idea of static method, we've covered it in 2 different books. In one of the books, they only mention the string class, the math class. So in this book, they only refer to the static method as examples in the math class. The math. So this one, the static methods are only done in the math class. Okay. But in this other book, the static methods are, we write our own. So the difference is, in this book, we wrote our own static methods. In this book, they talk about only the methods in the math class. They didn't write any static methods, but we're doing both. So in this book, we're seeing, well, somebody can give us a bunch of static methods in a file pre-written for us. That's an important idea. The math file is a good example of somebody writing a bunch of static methods for us to use. But we could also write our own static methods. And we learned how to do that in this chapter of this book. Okay, so when they use the word method here, they mean static methods. Okay, so this is static methods. Now, what about writing our own methods and objects? That comes later in the course. Over here with the turtles and the strings, we're not writing the methods in the turtle object. We're not writing the methods in a string object. They're written for us. That's like the math class. We're not writing the methods in the math class. These static methods were written for us. So these static methods were written for us. The methods in the turtle and the string objects are written for us. But over here, we wrote our own static methods. That's the simplest kind of thing. When we write our own methods, it's easier to start with writing static methods. Writing methods and objects are a little bit more complicated. So later, we'll talk about writing methods. We'll write our own methods in objects a little bit later. So we're using the methods that somebody else wrote in objects and strings. So we're using the methods that somebody else wrote in strings. We're using the methods that somebody else wrote in turtles. We will also use the static methods that someone wrote in the math class, and some other examples later on. Somebody else wrote the static methods in that math class. But then we'll also write our own simple methods that are static. Okay. So on the exam, there's a little bit of all this. On the exam, there are static methods that you have to know that are like in the math class that are written for you. Static methods that you have to write yourself, simple ones. Not usually, nothing more than a few lines, but you write your own static method in a class. And then a lot of using methods in things like the string class, turtle class. Actually, we've used methods in 3 kinds of objects: strings, turtles, and scanners. And we haven't done a whole lot with scanner. We'll go back and do a little bit more with scanner. So far, we've pretty much just used next line or next int. Okay. So, and let me go back to the homework assignment just to remind you that if you download the homework assignment, in the zip file, I put these things that kind of remind you what some of the methods are that we're using. I couldn't find a nice version of this on the internet, but there's some example methods that are in the string objects that were written for you. Okay, so these are the methods in a string object that you can use. Okay, so this is a nice table. I couldn't find a nice table like this on the internet. I copied this out of a book, so I stuck it inside this file here. And then here's a couple methods that are in the scanner class. Okay. Again, I couldn't find a nice summary like this on the internet. Like, I copied this out of a book and I put it in this file. Okay. And then there's also a list of methods in the turtle. In their book, I think it was, I can't remember, it was C. The book had a little summary of methods in a turtle. I think it was in this one. Here. See, there's a little summary of, that's not all the methods in a turtle, but there's some important ones. Okay, so there's now somebody else wrote those. We didn't write those methods in the turtle object. We get to use them. Okay, later on we'll start learning how to write our own methods in an object, but for now we use somebody else's methods in an object. There's turtle methods. There's string methods. Notice how we want somebody to tell us what the methods are. Now, the turtle method, when somebody tells us what the methods are, it's useful to remember, see what they tell you. They need to tell you the name of the method. Okay, they need to tell you any input parameters the method takes. They should tell you what the method gives you back. If it gives you back an answer, what answer does it give you back? And they should give you an example of what it does. Okay, so somebody should tell you the name of the method, what it takes as input, and what it gives you back as an output. Okay, now in the case of the turtles, notice that they do tell you, like this one doesn't take any input, no input, no input, no input, no input, no input. This one takes in an int that says how many steps forward the turtle should take. This one takes in an int that says how many steps backwards the turtle should take. This one takes in a double that says how many degrees the turtle should turn. Okay, so they're kind of giving you a sense of what they give you the name of the method, what it takes in. Now, what it gives back here, it's kind of obvious. Forward makes the turtle move forward. It actually doesn't give you back an answer. It makes the turtle move. So these don't give you back answers. They actually make the turtle move. Okay, so you want somebody you would like somebody to tell you what the name of the methods are, what they take as an input, and if it's appropriate, what they give you back as an answer. And an example, here they give you an example of using it, and they give you a description in English of what the method does. Okay, we call this documentation. When somebody gives us a table like this, we refer to that as documentation. Okay, and tables like these are important. I'll always try to give you a table like this when we learn something new. In fact, I think I want to make a better table for the turtle. I thought that this is the best table they have for a turtle. So it's not particularly great when they're missing a couple methods, but this gives you a sense of, along with all their examples, it gives you, here it's actually kind of obvious what forward, backward, turn left, turn right, pen up, pen down do. So they don't need too much English description of these things. These are much more subtle. These they do need English descriptions of them, because what they're doing is much more subtle. Turtles were designed to teach children programming. So the whole point of the turtle was to be real clear. I mean, the turtles were literally designed to make it easier to teach children programming. So the idea was that this should be almost self-explanatory, what these things do here. So they don't really need an explanation. They don't need too much documentation. String methods are a whole different thing. String methods, some of them are pretty tricky. So they need an example, and they need a verbal description. So you need to read what string methods do. Okay, so we've got methods and objects that we work with, and right now we have string objects, scanner object, and turtle objects. Those are the three kinds of objects that you've learned how to do some methods with. Okay, and then we have static methods that we would write. And the one example of static methods that we didn't write, that we have examples of, is the math class, which we'll learn a few examples. Okay, so the math class is an example of somebody writing for us a bunch of static methods. And then over here we have examples of us writing our own static methods. Okay, okay, now let's see. That's actually a summary of what we've been doing so far in this semester. What we've done today really has summarized everything we've done in in the first 4 chapters of this book and the first 2 chapters of this other book. Okay, so we've been talking about variables and methods. Okay, and we've talked about doing memory diagrams for the variables and the objects. Okay, so we talk about variables, objects, and methods. Actually, it's mostly what we talk about is variables, objects, and methods. And if you go here and look at the review of the exam, you see that variables, methods, objects. Okay, this thing expressions is this is this is the idea of working with your variables, adding them together, calling methods on. We call that expressions. Okay, so that's just the idea that you could manipulate variables. Okay, so expressions are anything that you do with the variables, call methods on them, add them together, do things like adding and subtracting and division. But the key things: variables, methods, objects. Okay, so yeah, and oh, notice that, yeah, static methods and methods in objects. Okay, so static methods and methods in objects. So we've very quickly summarized. This is what we've done in the last few weeks, and the idea is that you should be able to start now going through these ideas quickly. We spent 4 weeks talking about these things slowly, slowly, slowly. They should start now becoming something you can think about quickly. You know, you should be able to just go through this now and imagine in your head what you can do with variables, what you can do with what you mean. What does it mean to talk about a static method? What does it mean to talk about a method in an object? Okay, so now you should start. These things should start. You know, you should just start. You should, when you see these words, things should click in your mind about what they mean. So this is just a outline of it, and that's what we did today. We quickly outlined most of what's in here. Okay, all right. So now, at this point, we've done, this stuff here. Talk about these things here. We're ready to, on Wednesday we're going to start with this new reading assignment. It's actually a whole. I'm sorry, not that. We're going to start a whole new topic now. Something called logic condition, Boolean logic, Boolean expressions, and if statements. So we're going to start a new topic. It's in both books. So it's chapter 5 in this book and chapter 3 in the next book. Notice that these books cover the topics in pretty much similar order. These ideas we're covering in the order that most programming books would cover them in. So you can see that even in these 2 books, they're covering these ideas in pretty much the same order. They might have different chapter numbers, but they're actually in the exact same order in the book. So the next chapter in one book is 5, which is right after methods, and the other book is chapter 3, which comes right after methods, which is their chapter 2. Okay, so we'll start this on Wednesday. Then start looking at these review problems and just start looking at them. They're in the order kind of what is talked about here. So the stuff we're going to start talking about today, the if statements, they're at the end. So you won't see anything about if statements until you get to problem 14. Okay, so problem 14, the last few problems, that's what we're starting now. So all the way up to problem 13, that's what we've done. Okay, so what we've done is everything up to problem 13. That's what we've done so far. So you can look at those, you can start looking at those problems, you should be able to start doing them. And if you have questions about those problems, we can, on Wednesday, if anybody's got any questions about some of these review problems, we can start with those. Anybody got any quick question at the end here? Because we reached the end of the time. Anybody got a question? Okay, so look and also your homework, your program assignment, which is due after the exam. So your next program assignment, it's due after the exam. So I think I should make sure to check that. The exam is on.
I think it's next Monday.
I thought it was a due a week from today.
No, oh no, okay, yeah, because I might change that. It's hard to say because the homework assignment is good practice for the exam. Doing this homework assignment is very good practice for the exam. So it's due 2 days before the exam right now. So that's due. So right now, the homework assignment would be a week from today, and the exam would be a week from Wednesday. I'll think about it. The thing about the homework assignment, it's very good practice for what you have to be ready for the exam. So I want people to think about the homework assignment, not put it off. So I want you to work on the homework assignment and not put it off. And okay. So right now so the assignment due a week from today and the exam a week from Wednesday. Okay. All right. So I'm going to go ahead and stop sharing at this point, and we'll meet again on Wednesday. And if you have questions, especially about the exam or about especially anything we've taught, it's Wednesday would be a good time to start asking questions about. Make sure you understand all these things we've been talking about. Okay, so see you on Wednesday.